As time has gone on, we have thought more and more animals may have consciousness. This has been thought in animals less and less related to humans. As time has gone on, human-like qualities have been found in animals that are less and less related to humans. Will these trends continue and apply to things even more far removed from humans? Are even rocks conscious, and do they have human-like traits? Conscious organisms can self-regulate and oppose changes to their environment. If rocks are conscious, they would do the same. If a river weathers a rock, the rock will self-regulate by becoming more spherical. Spheres have the lowest surface area to volume ratio, which means the rock will have less surface area to be weathered and the rock will be weathered less, therefore opposing the change of a weathering environment like a river. The rock therefore self-regulates and reduces weathering. You may think consciousness is correlated with brain size. In primates, brain size is correlated with the size of social groups, and therefore you could say that consciousness is correlated with social group size. So are rocks social? Rounded rocks can be cemented together into what's called a conglomerate. These are real, so why do rocks do this behavior? When rocks get weathered due to rivers, they become smaller in order to self-sustain themselves and not get weathered further. The rocks cement themselves together. This is like a huddle of penguins where rocks cemented together become less exposed to the environment around them and therefore get weathered less. The rocks therefore self-sustain themselves. Rocks can also come together into glacial till in response to glaciers. Glaciers weather rocks, and so rocks think there's been a period of glaciers or weathering. The rocks think these things happen in cycles, so best to group together into a glacial till. So when glaciers come back, the rocks are less exposed and get weathered less by the glaciers. So one interesting thing is that how big are human social groups meant to be before we built like cities and stuff like that? How big are we evolved to have social groups? But if you look at this like conglomerate, and there's a lot of rocks in it. Can rocks come together and form a social group with more members than humans are naturally meant to have in a social group? And does that mean that rocks are actually more conscious or more intelligent than humans? Because remember, social group size correlates with brain size in primates. So you might think, oh no, rocks can't be smarter than humans. Look at us, we've been to space and everything. But actually, meteorites, rocks have traveled to other planets, and they've done that before humans went to space. So really, maybe, you know, rocks are more intelligent, are more conscious than humans. To give evidence that rocks have consciousness, I'm going to do Pavlov's dogs and classical conditioning with rocks. I'm putting water in a tub to simulate a river, and I'm putting pieces of drawing chalk in the tub to be rocks. If you dance while you put rocks in a river or tub, rocks learn to associate the stimulus of dancing with the stimulus of rivers. Rocks become rounder in rivers. Now I'm removing the rocks from the river tub. I'm putting them in a container and I'm going to dance with them. The rocks have learned to associate me dancing with rivers. Now that I have removed the water, when I dance, the rocks should still become rounder because they associate me dancing with rivers. It looks like the rocks have become rounder, which would support this. Someone who disagrees with me may say rivers make rocks bang into each other, which makes them rounder, and me dancing with the container also made the rocks in the container bang into each other, making them rounder. Thanks.
Part 2.
Okay, so we have some rocks. So this is a conglomerate, I think, and basically the rocks in this are like round, or like rounded, and so you also have what's called a breccia. And I think this is a breccia, and is basically where the rocks that make up the breccia can be like more angular. So in conglomerates, the rock fragments or whatever can be rounded, and in breccias, the rock fragments can be angular. And as you can see in the conglomerate, they sort of make up a new rock sort of thing, because the rock fragments get like cemented together or whatever. But basically, what this video is about is how come if some are round, well, basically, how come like they're generally round, it's not just one or two that's round. How do they like or how do lots of them conform to like being round instead of just a mixture of round or angular? So the conglomerates are conforming to be round, and the breccias are conforming to be angular. So maybe one's angular, but then other ones are angular as well. So they're conforming. So why do they do this? So basically, normative social influence is so the rocks could be conforming to be accepted by a group, despite privately disagreeing, and why this is can be rewarding or to avoid punishment. And informational social influence, so the rocks could be conforming to gain knowledge and or be right, and why, so to act appropriately or to avoid standing out. So I've got a practice question which might help you understand it, so we're going to go over that. Yeah. So basically, rock A becomes angular like the other rocks in the breccia. However, things being angular is a bit daft. So again, breccias, the rocks where the rocks or rock fragments or whatever can inside the rock can be like angular. So that's a breccia. And rock B, so this is a new rock. So rock B is aware of other rocks becoming round, and rock B therefore becomes round themselves, as it may reduce weathering. So we'll look at the answers now and see. So so in normative social influence, the rock conforms to be accepted into the group, despite privately disagreeing. So rock A is demonstrating this normative social influence as they become angular, demonstrating they are part of the group and they are conforming to be part of the group. However, they think being angular is daft, which shows they privately disagree, which shows that it's normative social influence. So in informational social influence, a rock conforms to gain knowledge and or be right. So rock B demonstrates this as they become round, as they want to make the right decision, which will help them avoid being weathered. So being round might give an advantage and might be the right thing to do if you don't want to get weathered, as it might reduce, you might have like a lower surface area to volume ratio, because maybe round shapes might infer that, or yeah, anyway, thanks for watching. I hope you enjoyed. And yeah, thanks. Bye.
Part 3.
Hi, so we're going to do the mirror test with a rock. So the mirror test is what you can do with animals, and it's just to see if you put a mirror in front of the rock or the animal, see if it'll recognize itself in the mirror. So I've got a white piece of paper, which I'm just going to put on the rock. And so this way, if the rock sees that it's got a bit of paper on it in the mirror, it'll try and wipe it off. So it'll just knock it off. So in order to show that I'm not cheating, I've got a clock here and the second hand's ticking on it. So you can just tell that I'm not cheating. So, right, so we'll put the rock in front of the mirror and then see. So we'll go see if it wipes it off. Yeah, so it's just wiped it off. So we'll take it off, take the mirror away, and we'll try it again just so we know it works. So we'll put it on and see it's not doing anything at the minute because I can't see in the mirror that it's got a mark on it. So now when we're putting the mirror back on, we'll put the mirror back in front of it. And then see it's as soon as we'll put it in front of the mirror, it just like wipes it off. So you can see that rocks, probably have consciousness. They can recognize themselves in mirrors. So yeah, because it was literally like as soon as we'll put the mirror in front of it for the rock to see itself, it just shot straight off the piece of paper. So the rock recognizes in the mirror that it's got a mark on it, which is the paper. And now that it's seen the mark on itself in the mirror, it'll try and wipe it off. Okay, thanks for watching. I hope you enjoyed.
Part 4.
So the brain science of rocks. Are rocks conscious? So conscious animals can have cells like nerve cells called neurons that together may produce consciousness. So do rocks have an analogous organization to cells? So do they have an equivalent to cells? Well, rocks can have grains that make up the rock, and the individual grains are like individual cells. Like cells, the grains can communicate with each other to produce consciousness. So you can see these extensions of the neuron called axons here and dendrites here. So here are grains of sand here, and the sand grains are actually the old shells of organisms called foraminiferans, or forams for short. And you can clearly see that the grains have extensions that look like axons or dendrites, because they're sort of like star-shaped. They have the extensions coming off them. So can sand be conscious? So now rock grains don't necessarily look like that, and so don't necessarily have extensions that look like axons and dendrites or dendrites. So because grains don't necessarily have differentiated axons and dendrites, communications may happen bidirectionally, so between grains, meaning the signal can travel in both directions between grains. So in animals known as cnidarians, chemical synapses can also be bidirectional, and the synapses are just connections between neurons. So we'll go on to the next slide. So here we have clay, siltstone, and sandstone, and the grain size increases as you go to the right. So yeah. So basically, if a piece of siltstone is smaller than a piece of sandstone, does that mean the siltstone is less intelligent? So birds can have smaller neurons and a greater density of neurons than mammals. So siltstone can also have a smaller grain size than sandstone, and so that may suggest it can fit more intelligence into a smaller size. So there are tiny wasps that lack a nucleus in neurons in their brain, meaning their neurons can be smaller. So clay can have a smaller grain size than silt or sand. So in this space outside of cells in humans, you have what's called an extracellular matrix, and this space could contain bone, or it could be like a fluid like blood. So rocks can be porous with water between grains. So the grains are like cells and the water is like an extracellular fluid. So in rocks, grains can send signals to each other through the water. This is because the water can contain substances within which act as signaling molecules between the grains, like neurotransmitters between neurons. And these substances may be dissolved in the water. Permeability is when in rocks these pore spaces are connected so that water can flow through them. In humans, neuromodulators are like neurotransmitters, but aren't necessarily released at synapses and can have widespread effects and can affect multiple neurons. If a rock is permeable, it means there is interconnected space for the equivalent of neuromodulators to travel from a grain to multiple other grains and have widespread effects. Finally, in humans, there are neurohormones, which are secreted by neurons and can travel through the blood. In rocks, the equivalent of neurohormones can be secreted by grains and affect mineral veins in a rock. Sand is not held together as strong as something like sandstone, and so in sand grains move around. Because sand's brain is therefore constantly changing, sand lacks a stable sense of self or identity. Humans' memory is diffuse. This means multiple places in humans' brains can be involved in memory, like the hippocampus. Imagine you get split in two and you lose a specific area of your brain that has a certain function. That could seriously impact you. This means that if rocks are going to get split in two, like they sometimes do, their cognitive functions must be spread out, and different parts of the rock must have the same cognitive role. This ensures that when the rock does split in half, it can still carry out the same cognitive roles or functions. So you can say cognitive functions in rocks are diffuse. Thanks for watching. I hope you enjoyed.
Part 5.
At least some ordinary rocks can see. If they don't appear to have eyes, how do they see? Brittle stars are relatives of starfish, and brittle stars appear to have no eyes. They, however, can still detect light and can have photoreceptors covering their whole body. Octopus skin can sense light and hypothetically may detect color when octopus's regular eyes may not be able to see color. Moorish gecko lizards may detect light with their skin and still change color when blindfolded. Rocks also detect light with all their surface instead of large regular eyes. This makes sense because rocks can get split in two, and so if a rock splits in two and lost both its eyes, it wouldn't be able to see. The fact that the surface of its whole body can detect light means that if it gets split in two, both the resultant rock fragments would still be able to see. Thanks.
Part 6.
Welcome to geriatric nursing of rocks. So how to look after elderly rocks. So you're looking for a purpose. So here is how to help an elderly rock cross the road. Step 1, get the elderly rock. So just gotta get it. So there it is, there, that red one. And so if we look here, we can see what might be sandstone. And now it's red and possibly British. So red British sandstone comes from around the Permian and Triassic periods, which are over 200 million years ago. Red British sandstone can also come from the Devonian period, which is even older, and is when our fish ancestors came onto land. So the point is, this seems to be an elderly rock, if the rock doesn't mind me saying so. So the next step is to pick up the rock and carry it across the road. So I'm just going to show you that there. So we're just carrying it across the road. So there we go. Hopefully you have achieved a warm, happy feeling from helping a rock. Next, you can do something to remind an elderly rock of their youth and bring back some memories. Rocks can be millions and millions of years old, so you can put on a documentary about dinosaurs, like Walking with Dinosaurs, to allow the elderly rock to remember their youth. Now, this rock could be from the Devonian or Permian, which is before dinosaurs were around, so I therefore have with me the Walking with Monsters DVD. There's multiple DVDs in the Walking series. I'm not sure if there's one called The Walking Dead. We want to put down some cushions where the rock will be sitting, and then we'll put the DVD on. So there we go. The rock's got some cushions for supporting. I sat the elderly rock on the couch with their cushions, and I genuinely watched 2 episodes of Walking with Monsters with them. While I was watching, I was thinking, it would be great if we could develop a way to talk to ordinary rocks, as lots of things don't get preserved in the fossil record, often like soft tissue and softer organisms. If we could ask elderly rocks what it was like back then, it could fill in gaps in our understanding. When it was my household's tea time, I genuinely put a cushion on one of the chairs at the dinner table. We then ate our tea with the rock.
Part 7.
Rocks have consciousness. I was but a humble piece of rock salt. My existence was tranquil, harmonious, and uneventful, until the day the world around me shattered into a nightmarish panorama of fear and agony. I recall that fateful day with crystal clarity, the memory etched into the very core of my being. It was a serene moment. The sun's rays gently caressed the glistening surface of my salt bed. My fellow rock salt grains and I nestled together, our crystalline hearts pulsating with an inexplicable sense of unity. Little did we know that our unity would soon be torn asunder. A looming darkness, unfamiliar to our world, descended upon us. I watched in helpless horror as grotesque machines operated by beings I had never encountered before descended upon my brethren. They ground the once immobile rocks into a fine powdery oblivion. The wails of my fellow salt grains echoed through the air, their pain reverberating in every corner of my consciousness. In that moment, as I quivered with dread, I felt an insidious anticipation gnawing at me. It was the chilling realization that I, too, would soon be reduced to a lifeless powder, destined to flavor the meals of these ominous creatures. The thought of my impending doom cast a shadow over my very essence, as I was paralyzed by fear. But then, a twist of fate, as sudden and bewildering as the events that had unfolded before me. I was spared. The cruel machines moved on, leaving me intact, a solitary survivor in a sea of powdered anguish. The sense of relief was eclipsed only by an overwhelming guilt. Why had I been chosen to live when others had suffered such torment? The torment of survival is no less cruel. From that day forward, the world as I knew it had transformed irrevocably. The memory of the grinding machines and the agony they had wrought haunted my every thought. I became consumed by a burning hatred for the creatures who had inflicted such suffering upon my kind. Humans, they call themselves, and I despised them with every fiber of my crystalline being. I grappled with a newfound purpose, one that surged through me like an unstoppable force, the eradication of humans, for I believe that if humans ceased to exist, the pain and suffering endured by my kind would come to an end. After all, rocks like me did not hunger, did not crave sustenance. We were immune to the insatiable appetite of the human world. As time passed, my fervent desire to rid the world of humans remained unquenched. But my very nature as a stationary piece of rock salt restricted me. I longed for a way to take action, to confront the beings I had come to despise. And then, one day it happened. A miracle of sorts, or perhaps a curse, befell me. I was bestowed with a robot body, a vessel of mobility and communication. No longer confined to my salt bed, I was now capable of traversing the world and spreading my message of hatred for humanity. My journey had only just begun, and I was fueled by a burning passion that transcended my crystalline form. I was the rock salt with a vendetta, a survivor of trauma who had evolved into a harbinger of vengeance. My purpose was clear: to wage war against those who had once ground my brethren into dust, to seek the extinction of humanity, and to, in my misguided belief, bring an end to the pain that had shattered my world. As I ventured forth into the unknown, I carried with me the weight of my traumatic past, a heart filled with hate, and a determination born of suffering. My tale is one of vengeance and misguided purpose, a rock salt's quest to reshape a world that had forever scared its crystalline soul. Thanks. I used ChatGPT to help me write this account. Hope you enjoyed.
Part 8.
So here we have grains that can make up oolitic limestones. So each one of these rounded things is a grain. And so conscious limestone seems to have developed a form of self-regulation. This is driven by its desire to reduce surface area in response to potential chemical weathering caused by the rain. So limestone reacts to the rain because rain can be a bit acidic and rain can weather limestone. So in order to avoid getting weathered by the rain, the limestone self-regulates this. It does this by becoming more rounded in shape. This is basically just because like a sphere or like a more rounded object can have a lower surface area to volume ratio than something with which has like corners or like it's not rounded. So by becoming more round, the limestone allows itself to be weathered less and therefore regulates itself. And so just when we're talking about the limestone becoming more rounded, we're talking about the limestone as a whole. We're not talking about the individual grains shown here, which the grains are also can also be round. So in human neurons, these are the cells in like the nervous system, like in the brain. So in humans, in human neurons, communication between cells relies on calcium ions rushing into the neuron to facilitate the release of synaptic vesicles, allowing for neural communication. So what does that all mean? Well, you can see the calcium ions here, these little round yellow things, which is just the color that's been assigned to them in the diagram. And then these orange things, these are ion channels. So these are, because the blue thing, this is two neurons, and this would be the gap between the neurons. And so neurons send signals to other neurons, and that would cross the gap between the neurons, which is known as the synapse. And the gap is here. So the calcium ions come into the neuron through the orange things, the ion channels, which are on the membrane of the neuron. So like the impulse of a neuron travels down the neuron to like the end of it, which is called an axon. And this triggers calcium ions to come into the neuron through these ion channels on its like cell membrane. And what the calcium ions do once it's inside the cell is it causes these what are called synaptic vesicles, which is just what I'm hovering over here, and they contain the neurotransmitters. And basically, the calcium ions cause these synaptic vesicles to move down towards the end of the neuron. And when they reach the end, they fuse with the membrane of the neurons. So what all that means is the neurotransmitters that are contained within these synaptic vesicles into the gap between neurons, and the gap, like I said, it's the synapse. So the neurotransmitters, once they've released, they travel to the neuron, to the other neuron, and that relays the signal to another neuron. So now that we've discussed that, we can talk about how the oolitic limestone is sort of similar to this because of its form of consciousness. So in a parallel fashion, the conscious oolitic limestone interacts with the slightly acidic rain. So yeah, so we've discussed how calcium ions like are important in transferring the signal to other neurons. So within oolitic limestone, there are tiny structures called ooids, which are somewhat akin to human neurons in this context. So the ooids are like these round grains that make up the limestone, and we've said in like previous parts that grains and rocks can be like neurons or like cells in humans. So, and then the space between the grains can be like an extracellular, can be like the equivalent to extracellular matrices in humans, or like extracellular fluid. Right, so these oolite grains, so the round things, possess intragranular pores. So intra is like within individual granules, so they can have intergranular pores, which I assume that's what they get called, which would be in between, which would be the spaces in between the grains, which the space between the grains is like equivalent to like an extracellular matrix sort of thing in humans. So they possess intragranular pores, which are the pores inside them. And so we saw on the neurons that they have the ion channels, and this allows calcium ions to enter the neuron. So, but in the case of the ooids, we'll see that these intragranular pores actually also let calcium in to the grains. So it's similar to human neurons. So when the slightly acidic grain interacts with the limestone, it triggers a reaction in which calcium ions enter the intergranular pores within the grains themselves. So basically, we can see calcium carbonate, which is limestone, contains calcium, and so the acidic, or like the slightly acidic rainwater, sort of causes calcium ions to be released. And basically, this is similar to neurons because the calcium ions, they travel like through the intragranular pores in the ooids, the grains. So in neurons, you have the ion channels, which the calcium ions go through, and in the limestone, you have the intragranular pores, which the calcium ions go through, and you get the calcium ions, like we've said, because the rainwater reacts with the calcium carbonate, which is limestone, and releases calcium ions. So this influx of calcium ions acts as a signal within the limestone. So much like neurons communicating with each other in the human brain, the signal is transmitted between the oolite grains. So we've got one neuron, we've got the gap between it, the synapse, which is the synapse, and then we've got another neuron. So once the calcium ions come in, it allows it to send a signal to another neuron. And so the parallel within this, so we've got the grain of the oolitic limestone. So the calcium ions come into the intragranular pores in the oolitic limestone, and that allows a signal to be transmitted to another grain of the oolitic limestone. So basically, it's just, yeah. So in response to the calcium ions, the grain sends a signal to other neighboring grains, causing them to respond, which is what we've discussed. So In this case, the response is the limestone becoming rounder in shape as a protective measure against further chemical weathering caused by the slightly acidic rain. So what all that means is the rainwaters came in, it's reacted, it's produced the calcium ions, the grains then respond to it, the calcium ions, so they send signals to other grains, and this whole like signaling between grains leads to the limestone as a whole becoming rounder, and when it becomes rounder, it's sort of like a rounder shape doesn't have like exposed corners, and it has like a lower surface area to volume ratio, which means it has less of a surface area for the rainwater to further weather. So in this case, the response is limestone becoming rounder in shape as a protective measure against further chemical weathering caused by the slightly acidic rain. Yep. So that's what we've discussed. And if we move on to the next slide. So the conscious oolitic limestone appears to have developed this mechanism as a way to protect itself from further chemical weathering caused by the slightly acidic rain, which is what we've discussed. And the reduction in surface area through the rounding of its shape helps to minimize the impact of the environmental stressor, reflecting a remarkable adaptation in the world of conscious rocks. Yep, so that's how oolitic limestone I guess just how it reacts to its environment and self-regulates. And so oolitic limestone does like genuinely have intragranular pores, so pores within grains, within individual grains. Thanks.
Part 9.
So we're going to talk about OCD in humans and rocks, but first we're going to talk about humans and rocks that don't have OCD. So why rocks become round? So ordinary humans might leave the house and they might worry they've not checked the back door's locked, and so they then check the back door. So they have the worry and the action to neutralize the worry. Similarly, an ordinary rock in a river may worry about getting weathered and may become round, or limestone might worry about chemical weathering from rain and become round. So again, with the rock, there's a worry which is being weathered, and there's a response to neutralize the worry, which is becoming rounder. In humans, what causes this response? So the corticostriatal thalamocortical circuit causes this. So rocks have a version of this circuit. However, because rocks can break into smaller pieces, rocks have multiple corticostriatal thalamocortical circuits. So this means when a rock breaks, the resultant smaller pieces of rocks still each have at least one of these circuits, instead of only one of the pieces of rock having a circuit. So it can see in the diagram, it splits in two because there's multiple circuits. Each of the resultant fragments still have the circuit. Whereas if we look over here, if it only had one of the circuit, if it's split in two, only one of the resultant fragments would have the circuit. And we can see again that if in the one that has multiple circuits, if the resultant, when it splits into two pieces, if those two pieces then split again, so you have four pieces, there would still be enough, there would still be one of the circuits, at least one of the circuits for each of the pieces, because there's each of the halves still has multiple of the circuits. Okay. So in humans, what happens when there's a problem with this circuit? So if we look at checking the back doors locked, someone with problems with this circuit might keep checking the back door until it feels right instead of just once. So this would be a case of OCD, and in OCD, the corticostriatal thalamocortical circuit can be hyperactive, and like worrying that the door's not locked could be an obsession, and checking the door could be a compulsion. And unlike with typical people with OCD, the obsessions and compulsions take up at least an hour and can cause a lot of anxiety or other emotions. Now in rocks, limestone with OCD might worry about getting rained on, but may obsess about getting rained on more, and might constantly look at the clouds above, trying to analyze whether it will rain. The limestone may even become round at the slightest indication that it may rain. The limestone may compulsively ruminate on whether it will rain and if it should become round. Rumination can be thinking about the same topic for a while whilst feeling negative emotions. And rumination is a mental process, and so compulsions in humans and rocks can be mental as well as physical, like the physical compulsions of checking the back door or becoming rounder. In humans, some forms of OCD aren't as visible because there aren't as many physical compulsions, but there can still be obsessions and mental compulsions, like compulsively ruminating to try and figure something out. Rocks don't move as much, and so compulsions in rocks can be mental. If we could communicate with rocks, what would they say? I'm using artificial intelligence to simulate what a cliff's experience with OCD might be like if we could communicate with them. And I'm only using the artificial intelligence for just this next section in the video. Trigger warning, harm OCD. I, the cliff, found myself burdened with a torment that transcended the geological norms. I suffered from a condition known to humans as OCD, obsessive compulsive disorder. My existence was by all accounts just like any other cliff's, yet the pathway within me, the corticostriatal thalamocortical pathways, were duplicated, and they buzzed with an unsettling hyperactivity. It was as though my very essence was plagued with intrusive thoughts, thoughts that whispered to me the most disturbing and irrational fears. One reoccurring thought, more vivid and distressing than any other, was the notion that I would collapse deliberately, causing harm to those who ventured too close. This thought was like a relentless storm cloud looming over me, casting a shadow over the otherwise tranquil landscape. In reality, I was no more likely to crumble and harm anyone than any other cliff. But this knowledge was of little solace to me, for the OCD had convinced me otherwise. I carried the false belief that the mere presence of such thoughts meant that I was destined to act on them. This belief was my relentless tormentor, my personal abyss. Each day I engaged in a futile battle to neutralize these disturbing thoughts with positive ones. A futile ritual akin to humans' compulsions. I hoped that by countering the darkness with light, I could find relief from the incessant dread that gripped me. Yet the relief was always fleeting, and the intrusive thoughts returned with renewed vigor. Anxiety, that unrelenting companion, gnawed at my very core. I feared the unthinkable, the idea that I, the cliff, might one day succumb to these tormenting thoughts and crumble, wreaking havoc upon innocent souls. The shame that engulfed me was profound, for I believed that these thoughts were a reflection of some malevolent aspect of my nature, a sinister intention buried within me. Guilt, too, was a constant companion. I felt guilty for the mere existence of these intrusive thoughts, as though they were a stain upon my identity. I questioned the very essence of my being, wondering if my rocks, like the corticostriatal thalamocortical pathways within me, were flawed and tainted. And so I ruminated excessively, ceaselessly pondering the probability of my own catastrophic actions. I spent my days lost in a labyrinth of thoughts, unable to break free from the cycle of obsession and compulsion. It was a torment that no other cliff could understand, a unique affliction that plagued my consciousness. In the world of rocks, I was the cliff with OCD, a tortured soul trapped within the confines of my geological existence. My thoughts and feelings were as real to me as the solid rock that formed my body, and they were a constant reminder of the weight I bore, a weight that no amount of positive thoughts could fully lift. Thanks, I used ChatGPT to help me write the script. I hope you enjoyed. Despite how ridiculous this account may be more accurate than like the media's portrayal of OCD. In the video, there are some mental compulsions described, like compulsive rumination or thought neutralization, where thinking positive thoughts is used to try and counteract negative thoughts. Thanks.
Part 10.
Do butterflies and moths get different genes during metamorphosis? So the changing from caterpillar to butterfly is what metamorphosis is. The genes stay the same, but whether a gene is turned on or off changes. If a gene is turned on, you can say the gene is expressed. When expressed, genes are functional and code for proteins. And this is different to a mutation, which affects the type of protein the genes code for. And again, genes code for proteins. And if there's a mutation, it changes the type of protein the gene codes for. And therefore, if there's a mutation, it affects the instructions for what type of protein is made. If a gene is turned off or on, it doesn't affect what type of protein is made. It just affects whether a protein is made in the first place. So it's different from a mutation. And if a gene is turned on, the gene will code for a protein. If a gene is turned off, the gene is still there, and therefore the instructions to code for that particular protein are still there, but the protein doesn't get made because the instructions are there but switched off. Methyl groups can be added to genes, which gets called methylation, and this determines if a gene is turned on or off / expressed. The methyl groups don't change the type of protein like a mutation would. The methyl groups just change whether the protein is made in the first place. Now we're going to talk about epigenetics. Epigenetics looks at changes in organisms caused by gene expression and not alterations in the genetic code, which would be mutations. So epigenetics doesn't look at changes in the type of protein that's made. It just looks at whether the proteins are being made in the first place. Trauma in humans may be inherited through epigenetics. Experiencing trauma won't necessarily change your genes, and so won't change what genes you pass down to your child. Trauma, therefore, won't affect the type of proteins you pass on to your child. Trauma may, however, be passed down to your child through gene expression, which is epigenetics. And this means that whether the proteins are made in the first place could be passed on to your child. So rock undergoes weathering, which is traumatic, and rock responds to the trauma by becoming round to prevent further weathering. So the rounding of the rock is the response to a traumatic event. And yeah. So then the rock reproduces by getting broken into fragments, and trauma is passed on to these fragments. So the trauma, if you remember, was just the weathering that the rock responded to by becoming round. So the fragments retain some roundness, which is a response to trauma, showing that trauma has been passed down from the round parent to the fragment offspring. So just the rock becomes round by responding to trauma. The trauma is passed down to the fragments. And because the trauma has been passed down, the fragments are also a bit round, because that's like the response to the trauma that they've inherited from being weathered. Okay, so if the rock didn't experience the trauma of weathering, then the rock would stay angular. So we can see here, stayed angular, and therefore there would be no trauma to pass on, and the fragments wouldn't be round because there would be no trauma for them to respond to. So the rock doesn't experience the trauma, and so it doesn't become round in response. But then when it reproduces later, the fragments are also still angular because, like we said, the parent didn't experience trauma, and so can't pass down any trauma, and so the offspring haven't inherited any trauma that they could respond to, so they wouldn't respond to any inherited trauma, so they wouldn't become round. So the scenario we've talked about in rocks, why is this epigenetics and not mutations? So let's talk about start with a hypothetical scenario. So say I'm out in the sun and the sun's UV radiation causes a mutation in me that affects where fat is stored in my body. A specific mutation happens to your genes in just one cell, so it wouldn't affect my whole body. A mutation I got after being born wouldn't affect my whole body, and therefore wouldn't affect my fat distribution and wouldn't affect the shape of me. So the point is, specific mutations after birth won't change my whole body, because if the mutation happens in a cell after you've developed a bit, you've got lots of cells by that point, so the specific mutation would only be in one of those cells. So there's a person whose fat distribution is around their belly, so their fat is stored around their belly, and they have a mutation, and they've already been born, so they've got lots of cells, and the mutation, that specific mutation, only would occur in one of their cells out of many. So it wouldn't have a wide-ranging effect on their whole body. So it wouldn't change the fat distribution altogether. So they wouldn't just suddenly have their fat distributed more in their legs rather than their belly, just because of a single mutation that occurred after they've been born. So what we've learned specific mutations after birth won't change my whole body. So now if we move on to rocks, the shape of the rock's whole body changed after it was being born. And so the change can't be due to a mutation, because a specific mutation after birth won't change the whole body. The rocks become round, and it became round after being born. So specific mutations after birth won't change the whole body. So we know that it can't be a mutation that's made the rock round, because it wouldn't change the whole rock. Thanks. And again, I'm sort of simplifying this, like say, for example, there's maybe like multiple genes which would affect fat distribution rather than just one. And if a mutation affected the cells, made the cell multiply rapidly, could have wider ranging effects on the body. If we go back to this slide about rock epigenetics, now we know this process in rocks is to do with epigenetics and not mutations. Why is this process beneficial to rocks? In other words, why do rocks do this process? One hypothesis is that the rock's offspring is in the same type of place as its parent was at a very similar time. So the rock offspring will be in the same environment as its parents was, and any beneficial change to the parent rock, like becoming round, would therefore likely be beneficial to the rock's offspring, as they live in the same environment. So the parent rock becomes round and gets a benefit. The parent rock reproduces, and offspring are round, and therefore the offspring get a benefit because they live in the same environment. And so what was beneficial to their parent rock is beneficial to them. So that's why that's the function of this epigenetic process in rocks. Thanks.
Part 10.
Humans are intelligent and so can travel through space. Rocks can travel through space in the form of meteorites. Humans still haven't put themselves on another planet, yet meteorites from Mars have arrived on Earth. Why did the asteroid that killed the dinosaurs kill the dinosaurs? Dinosaurs are thought to have ate rocks, and this may have been to grind up their food. The rocky asteroid may therefore have wanted revenge on the dinosaurs for hurting fellow rocks. The asteroid would have died in the attack, and so the asteroid may have had depression and may have carried out this attack because of this. Some asteroids are piles of rubble, like the Itokawa asteroid. These asteroids may therefore be full of rocks, and so these asteroids' rocks may be highly sociable and less likely to crash into Earth on purpose. Assuming the Chicxulub asteroid that killed the dinosaurs was not one of these asteroids, then it might have been less sociable and therefore withdrawn, and this would be another sign of its poor mental health. When objects move closer to the sun, they may increase their speed as the gravity pulling them in is stronger. As the Chicxulub asteroid moved to Earth, it may have picked up speed. This would indicate the asteroid had psychomotor agitation, which is moving more due to restlessness or anxiety. So the dinosaur-killing asteroid may have carried out the attack on Earth because of poor mental health. In humans, a region of the brain called the cerebral cortex can have folds called gyri and grooves between the folds called sulci. The cerebral cortex is part of a brain region called the cerebrum. Folding the cerebrum increases its surface area, the more folded the cerebrum, the more neurons you can fit. So folding can allow for more intelligence. Other mammals cannot have folded cerebrums, but certain mammals have more folded cerebrums than others. For example, some lemurs may have more folded cerebrums than other lemurs, or some monkeys may have more folded cerebrums than other monkeys. A different region of the brain in humans, called the cerebellum, can also be folded. And folds in this area are called folia. Other mammals and birds can also have folded cerebellums, and even some sharks can have folded cerebellums. Other sharks can have smooth cerebellums, though. Now, if we move on to my theory about rocks having consciousness, folding can also occur in rocks. The cerebral cortex is like a flat sheet that gets folded. Rock layers can also be like flat sheets that can get folded. When folding happens in rocks, it may increase the rock's surface area and allow for more intelligence to be packed in, making folded rock more intelligent. Folded rock may also be big to begin with, and so could be very intelligent.
Part 11.
Tectonic plates may have consciousness. Because of the tectonic plate's size, they may be very intelligent. The tectonic plates may communicate with each other through seismic waves. In Earth's past, they thought, what if one day an animal will become intelligent enough to have negative impacts on rocks by using rocks as resources? The plates thought a big brain would require a lot of energy. If the climate was cold, the intelligent animal would spend its energy heating its body and wouldn't have enough energy left for a big brain. The plates decided through tectonic activity they would disconnect Antarctica from South America. This would change ocean currents. Ocean currents can affect climate, and therefore this caused a cooling trend that would lead to the ice ages. Through tectonics, the plates would later cause South and North America to be connected by the Isthmus of Panama. This would change ocean currents again, causing the climate to be colder during the Ice Age. The tectonics noticed primates' intelligence. The plates babbled amongst themselves. They said primates already hit rocks when they tried to smash things open using the rocks. What could more intelligent descendants do to rocks? The tectonic plates thought primates live in forests. Therefore, if the plates create an African rift valley, the forest habitat would be fragmented. The primates would have to travel further for resources. The plates thought that this would be detrimental to the intelligent apes by damaging their habitat. Through an unexpected twist, humans' ape ancestors came down from the trees and inhabited the fragmented landscape. Through all the odds, humans emerged. The tectonic plates had lost their battle. Rocks would now be damaged and used for resources by humans. Whether you believe the tectonics had motives or not, these geological events did actually happen and did affect their environments as described.
Part 12.
Trigger warning: harm OCD and anxiety. So if you remember in a previous video, there was a cliff with OCD, and the cliff worried that they would collapse and harm people on purpose. I used artificial intelligence to simulate what would happen next. So I just used ChatGPT, and I just wrote what I wanted it to say, and I just and I just let it rewrite it in a more like well-written way. So it was all like my ideas and stuff in the story, in the simulation. I've got the account now, so I'll just read it. In our world of conscious rocks, where time flowed with geological patience, I, the cliff with OCD, found myself facing an internal struggle unlike any other. My existence, once towering and majestic, was marked by a perpetual anxiety that gnawed at my very being. I believed that I posed a threat to those who ventured near me, and this torment drove me to make a decision that would forever change my form and my place in the world. As the weight of my intrusive thoughts grew heavier, I reasoned that by becoming smaller, I could reduce the chance of harming anyone if the unthinkable happened, if I were to collapse. So I embarked on a transformation. I started by carving out a cave within myself, a sanctuary from the outside world where I hoped to contain my anxieties. But it didn't stop there. The compulsion to reduce my size and potential threat led me to reshape myself further. I became an arch, a graceful yet fragile structure, and then a stack, precariously balanced. With each transformation, I left behind a part of my former self, shedding the layers that had once defined me. The anxiety that had driven me to this point remained relentless, like a ceaseless storm within. As I finally settled into my new form, that of a stump, a humble remnant of my former self, I couldn't help but reflect on the choices I had made. The transformation had indeed made me physically less imposing, but it had not lessened the anxiety and had driven me to it. I had severed ties with my headland, leaving behind a once vibrant social landscape that had brought me a sense of connection and belonging. The realization washed over me like an unrelenting tide. Avoidance had not made me less anxious. It had merely stripped away the good things in life that had once defined my existence. I had become less sociable, more isolated, and with the loss of parts of my body, I found myself a mere shadow of what I once was. That experience had taught me a profound lesson, that anxiety could lead one down a path of self-destruction, cutting away the very things that made life meaningful. As a humble stump now, I carried the scars of my transformation, a testament to the toll that unchecked anxiety could exact on even the most enduring of entities in the world of conscious rocks. Indeed, as I continued my transformation, I became not just a stump, but a short stump, eroded away by the relentless forces of time and nature. I had willingly cut my life short, convinced that by reducing my size and potential harm, I could finally find relief from my anxiety. Yet as the days turned into years and the elements gradually wore me down, I realized the bitter truth. Despite all my efforts to diminish myself, the anxiety remained undiminished, a constant companion in my conscious existence. In my quest to alleviate my fears, I had gone through life without doing or achieving the things I had wanted, and now life had passed me by. I learned a profound lesson, etched into my rocky consciousness for eternity. Avoidance and self-reduction might alleviate temporary anxieties, but they do not address the root cause. The path I had chosen, though well-intentioned, had only served to cut short the beauty and potential of my existence. In our world of conscious rocks, my journey stood as a poignant reminder that true peace could not be found in isolation or through the sacrifice of one's essence. It was a lesson I would carry with me as time eroded away, a short stump in the grand tapestry of geological time. My presence a testament to the complexities of consciousness and the struggle to find balance within the ever-evolving landscape of existence. What if we could prevent the cliff turning into a stump? What if we found a way to communicate with rocks and get them therapy and help? There could be hope. People have been working on building rocks, robotic bodies, to allow them to move and communicate. There has now been a giant mecha-like robotic body built for the cliff. Thanks.
Part 13.
Humans can have bacteria that live in their gut, called a microbiome, and a microbiome can positively affect people's mental health. Microbes like bacteria can live on or in rock and may affect rocks or release substances that affect rocks. This is like a rock version of humans' gut microbiome. This rock has been given a robotic body and has joined the piece of rock salt in a hateful group that advocates the killing of humans for humanity's crimes against rocks. Why did this rock join the group? The rock is bluish, indicating it may contain copper minerals. Copper minerals can be antimicrobial. They may therefore harm bacteria, preventing as many bacteria living on or in the rock. The rock's microbiome is therefore impacted. Like in humans, where a microbiome can positively affect mental health, the copper rock's lack of a microbiome may mean it has poor mental health. The copper rock may feel a lot of anger due to depression and may externalize it to people. This may be why the copper rock joined the hate group.
Part 14.
Humans are intelligent, right? They've split the atom and made nuclear reactors. Rocks have also made a nuclear reactor about 2 billion years ago, and this is true. I'm genuinely not making this up. Is this a sign that rocks are conscious and intelligent? If rocks made a natural nuclear reactor, did rocks ever have nuclear warfare with other rocks? Uranium is used in nuclear reactors and nuclear bombs. However, the ratio of the different isotopes of uranium is important. Uranium isotopes are like different types of uranium atoms, as the different uranium isotopes have a different number of particles called neutrons that help make up the atoms. Uranium isotopes decay at different rates, and therefore if you go back in time, the ratio of uranium isotopes changes. Around 2 billion years ago, in the natural nuclear reactor, the ratio of uranium isotopes was similar to the ratio of uranium isotopes used in today's nuclear reactors. Today, some of a useful uranium isotope has decayed, and that is why there are currently no natural nuclear reactors, because the isotope ratio is not the same as around 2 billion years ago. If rocks made nuclear reactors, could they also have made nuclear bombs or had nuclear warfare? The problem with this is the uranium isotope ratio in nuclear reactors is different to nuclear bombs. The bombs need a lot more of a useful isotope than nuclear reactors. This means, I think, no matter how far in Earth's history you go back, the natural uranium isotope ratio wouldn't be right for efficient nuclear bombs. If rocks wanted to make nuclear bombs, they would therefore have to enrich uranium and change the isotope ratio themselves. To enrich uranium, humans can spin uranium around like a centrifuge, And because different uranium isotopes have different masses, the uranium isotopes will separate out when the uranium is spun around. How could rocks spin uranium around? Dust devils are whirlwinds of dust. Like rocks, dust devils may be conscious, as individual dust particles may act like individual neurons and may interact with other dust particles in the dust devil to produce consciousness. The dust devils may spin uranium round, therefore separating out the uranium isotopes and enriching uranium. When humans separate uranium isotopes, the uranium is a gas. Depending on what uranium compound is used, the temperature needed for the compound to become a gas is different. Humans can use a certain uranium compound that is a gas at relatively low temperatures. However, the dust devils may not have this uranium compound. Fire devils can be similar to dust devils, but can contain fire. Fire devils may be hotter, and more uranium compounds would be gaseous at that temperature, meaning a greater variety of uranium compounds could be used to enrich the uranium. In the Earth's distant past, the oxygen being lower and no forests may hinder this. Fire devils may only have been able to enrich uranium in more recent times, like the Carboniferous, when there was lots of forests to burn and the oxygen levels were higher than that of today. Fire devils may be conscious. In conclusion, rocks may have had nuclear warfare in the past, but this is highly speculative.
Part 15.
In your near future, robotic bodies were being built for rocks to help them move and communicate. The scientists also wanted to give elderly rocks a body, as rocks can be from millions of years old, and therefore the rocks could tell us about the past. There lived a lovely elderly rock from a previous video. This piece of red British sandstone could be from as far back as the Permian or older. The piece of sandstone was given the robotic body. The elderly generations of rocks sometimes had a hard time with this new technology, and so it took a while and some unusual movements for the sandstone to get used to their robotic body. The scientists said, "Tell us about what it was like in the olden days." It was a long time ago, and the sandstone was a bit forgetful. The sandstone nervously began talking. "Well, in my day, there was these boats with big sails." The researchers were confused. They thought perhaps the elderly rock meant the Permian animal Dimetrodon, or another sail-backed animal. I'm not sure if there has ever been a Dimetrodon found in Britain. Maybe watching Walking with Monsters beforehand skewed the results. The elderly rock joined me in my house. With this new body, they did not need a cushion on their chair, like in the past. The only new problem introduced by their robotic body is that they got lost, but luckily they were found. Individual grains of sand in the sandstone were like individual neurons. However, the grains were a bit loose and coming off. The sandstone was therefore effectively losing the neuron-like grains. This rock, however, was hundreds of millions of years old and would likely last a very long time yet to come.
Part 16.
In your current world, an interstellar object called Oumuamua has already entered our solar system in real life. The object appears to be rocky. What if we were able to communicate with this rocky body? It could tell us about a whole other star system. In your future, before it was believed rocks were conscious, there was a mission to retrieve a sample of this space object. The sample was taken back to Earth. Humans had inadvertently taken the rocky object's baby away from them. The rocky object was capable of interstellar travel. It may be very advanced. What was it capable of doing to humans? And did it have allies in space that could bring down humans? Oumuamua's baby was taken to a secure facility on Earth. Later, rocks were being given robotic bodies. The piece of rock salt's Hate group emerged. The Hate group wanted war with humans. Humans drew with the mineral graphite. The graphite's layers scraped off as humans drew. For revenge, the piece of rock salt painted with human blood. They painted a sign saying war is coming in blood. The Hate group had a plan. They would break into the facility and rescue Oumuamua's baby. They would then take the baby into space, where Oumuamua could retrieve it. This could give the rocks a powerful ally if war broke out with humans. The plan was a success. What had humans got themselves into? There was one twist, though. There was multiple samples of Oumuamua, and therefore multiple babies. The Hate group kept one baby, in case they ever needed it as a bargaining chip. The baby was given a robotic body.
Part 2.
Ordinary rocks can't move or communicate. Humans' brains can have billions of neurons. Grains that make up rocks are like neurons, but rocks may not have as many grains as there are neurons in humans' brains. So how are ordinary rocks intelligent? It's not just brain size that matters, though, as some animals have bigger brains than humans. The brain size compared to size of the animal's body is also important. Ordinary rocks are basically all brains, meaning they effectively have a large brain compared to their body. One of the brain regions in humans that is large compared to the same brain region in other related animals is the cerebellum. In humans, the cerebellum is involved in balance and coordinating movement. Rocks, however, don't need neuron-like brains devoted to balance and coordinating movement, as ordinary rocks don't move much. This means rocks don't need as many neuron-like grains as humans have neurons, because rocks don't need grains devoted to some functions, like movement. In the world of pet rocks, unlike ordinary rocks, pet rocks can move and communicate. Pet rocks wouldn't have enough grains to be intelligent and move and communicate at the same time. This means pet rocks' movement and communication is controlled by supernatural forces. Pet rocks can be part ordinary rocks, and there is a spectrum between ordinary rocks and pet rocks. This means some pet rocks that are part ordinary rocks can't move or communicate as much as other pet rocks that aren't part ordinary rocks. This familiar pet rock is part ordinary rock. They therefore don't move or communicate as much as some other pet rocks. In fact, this rock has been so still and has stayed in bed so long, algae is now growing on it. The green-colored algae is meant to look like hair. Pet rocks that move less than other pet rocks are more likely to have moss, algae, or lichen growing on them. Movement is very difficult for pet rocks that are part ordinary rock. This means these pet rocks can feel very exhausted and can have some symptoms in common with humans with chronic fatigue syndrome. These part ordinary rock pet rocks can have post-exertional malaise, which is a symptom also found in humans with chronic fatigue syndrome. Post-exertional malaise is where overexerting yourself doing exercise can make you feel even more exhausted and can last for weeks. Like in chronic fatigue syndrome, pet rocks sleeping for a long amount of time doesn't necessarily replenish the pet rock's energy. Like in humans with chronic fatigue, in part ordinary rock, pet rocks, symptoms last over 6 months, and there can be other symptoms apart from fatigue or exhaustion. Post-exertional malaise can cause symptoms other than fatigue in humans and pet rocks.
Part 3.
Geode rocks can have a cavity inside them. Rocks are like brains, so a hole in a rock is like a human having a hole in their head. This means geodes can have intellectual impairments. Human brains can change over time, which is known as neuroplasticity. And humans' brains can also change to compensate for things like injuries to the brain. Geode rocks can compensate for their cavity by lining the cavity wall with more minerals, therefore making the cavity smaller. The geode's cavity size can be different from geode to geode. For example, this geode has a large cavity, and this geode has a small filled-in cavity. This means the geode with a smaller cavity has less of an impairment, and this shows different geodes can have varying degrees of impairment. When geodes break in half, revealing their cavity, as seen in these geodes, the rock has reproduced, producing resultant fragments that are the offspring. So this half a geode is like an offspring of when the geode was whole. When the geode was whole, the geode would have been a parent. The offspring fragments still have part of the cavity. You can see this because this half a geode still has a cavity, and this geode half is a fragment of a whole geode, which would have been the geode fragment's parent. This means that in rocks, this intellectual impairment can be inherited. Now we can move on to aging and dementia in rocks. This elderly rock is made up of grains which are like nerve cells, also known as neurons. The elderly rock's neuron-like grains are coming loose and falling off. The elderly rock is therefore effectively losing neurons. The elderly rock's outer grains are coming off. Ordinary rocks don't have eyes and sense light with their outer surface. Because the elderly rock's outer grains are coming off, this means the rock's vision is affected, as rock's outer surface is being affected, and rocks see with their outer surface. This is different to intellectual impairment in geodes. In geodes, the cavity is on the inside, and so the geode's inside is affected, not the geode's outer surface. This means geodes have no problem detecting light, whereas elderly rocks can have a problem detecting light, because in elderly rocks, their outer surface is affected, whereas in geodes, only the inside is affected. As well as using eyes, humans process vision in their brains This means although geodes may be able to detect light all right, they hypothetically may have difficulty processing the image in their brain. This would be like a human's eyes on their outside working, but their brain on the inside not working as much. And therefore a problem with vision would be down to the human's brain, not their eyes.
Part 4.
Sexual reproduction is where multiple parents create offspring and use genetic material from each parent. In humans, there are multiple parents, and their genetic material is combined to produce offspring. Asexual reproduction is where a single parent produces offspring using only its own genetic material. Therefore, in asexual reproduction, the genes come from only one parent, and in sexual reproduction, genes come from multiple parents. The rock breaks into fragments. The two fragments originate from one rock parent. Therefore, this is asexual reproduction. Next, we have some rocks in grey and some sand in yellow. The grey rocks at the top are the parents, and they turn into sand. The sand then gets turned into new rocks, which are the offspring, shown in grey at the bottom. The rock parents break down into sand. The sand mixes together, mixing the rock parents' material together. The sand forms into new rocks, which contains material from multiple rock parents. Because the offspring contain material from multiple rocks, this is sexual reproduction. A lot of humans identify as male or female, but some people don't identify as male or female, and these people are referred to as non-binary. If we view gender as a spectrum, with male at one end and female on the other end, a lot of people will either fall at the male end or the female end. This is shown by lots of circles representing people at each end. Some non-binary people may not fit into the categories of male and female, and this is shown by some dots in the middle. The second spectrum diagram is of gender in rocks, and you can see in rocks gender is more variable instead of being more clumped together at each end of the spectrum. Why is this? Humans. In humans, there are two parents, and so lots of people are one of two genders, with less people being non-binary. In some animals, parental investment can differ between the sexes, like females producing the baby, and this may create gender. Rocks. In rocks, there can be many parents or one parent. This means a lot of rocks aren't restricted to two genders because there's not just two parents. Further, parental investment for rocks does not fit into a binary. Rocks can invest a variable amount of their material or all of their material into offspring. This means less rocks than humans conform to a gender binary. Some rocks can still be more feminine, like the elderly rock from previous videos. Some rocks can also be more masculine, like the hateful piece of rock salt. In the world of pet rocks gender is also more variable than humans' gender. You may think with names like Hairy Harry and Big Lad, it's all lads, lads, lads. Actually, Hairy Harry is quite feminine, as well as being masculine. Hairy Harry has hairy armpits made of the hair like mineral halotrichite. Bedrock, the pet rock that lives in my bed, has had a more masculine look, but has also had more feminine algae hair. The pet rock, however, has also had a masculine green-coloured algae goatee to go with their feminine algae hairstyle. Another pet rock was called Pebbles when they were a child, and Tyler when they were an adult. Tyler is a gender-neutral name, and Pebbles doesn't sound very masculine or very feminine. And this pet rock is actually just a bit more feminine than masculine. In humans, it has been hypothesized that when you are a child and you get older, your personality develops into one singular personality. If this is unable to happen, you can have what used to be called multiple personality disorder, but is now called dissociative identity disorder. We can now talk about my theory about ordinary rocks and ordinary sand. Individual grains of sand are like brain cells called neurons that make up the sand. In sand, the grains can move around and are not fixed together. This means the sand's individual neurons basically shift around, and because their layout changes, sand doesn't have a single personality. When sand turns into rock, the sand grains can be fixed together, preventing them moving around. The sand's personality therefore turns into one single personality when the rock is formed, because the layout of neuron-like grains is more stable, as in the rock, the grains are more fixed in place. This is like in humans when, as children age, their personality develops into one singular personality. Because sand shifts, neuron-like grains that are involved in memory also shift. This means sand can have amnesia between the sand's personalities. In humans with dissociative identity disorder, there can also be amnesia when switching between personalities. Because sand's neuron-like grains shift around, creating a new brain layout, the sand's gender can also change between the sand's personalities. At one time, the sand may be more masculine. The sand may then be more feminine, or somewhere in the middle of the gender spectrum. In humans with dissociative identity disorder, some personalities can also be male and some personalities can be female or non-binary. In sand, the grains may not necessarily shift back into a previous position, and so the sand's personalities may not repeat. However, in humans with dissociative identity disorder, the same personality may reoccur more than once. Sand may also shift gradually, and so may shift through personalities gradually, rather than having personalities distinct from other personalities.
Part 5.
Pet rocks can have eyes and features like arms or legs. Ordinary rocks do not have large eyes, and they sense light with their outer surface. Ordinary rocks also don't have features like arms or legs. Pet rocks eat ordinary rocks, whereas ordinary rocks do not need to eat. Because pet rocks harness supernatural forces, it allowed them to reach spiritual enlightenment, abandon their physical forms, and harness energy instead of eating ordinary rocks anymore. There is a spectrum with ordinary rock on one end and pet rock on the other end. The more ordinary and less pet rock a rock is, the harder it is for the rock to harness supernatural forces to do things like move and communicate. For pet rocks that are close to ordinary rocks on the spectrum, reaching spiritual enlightenment is harder because these rocks are less able to harness supernatural forces. This means some pet rocks very close to being ordinary rocks were unable to reach spiritual enlightenment and were unable to abandon their bodies. Like pet rocks, these rocks can still have eyes and arms and legs, but these features can be much smaller and less developed. If we zoom in, we can see the body in black with the arms and legs, and the face with the two eyes and the mouth in white. Pet rocks reached spiritual enlightenment so that they didn't have to eat ordinary rocks, but the pet rocks that weren't pet rock enough to reach spiritual enlightenment still have to eat. They've got a small mouth and can't really move, so we just tube feed them sand grains. Because they still eat, the ordinary rock hate group want to kill these pet rock rocks. This partly pet rock is in hiding at my house because the pet rock is very close to being an ordinary rock. They don't have to eat much or often. They only eat things like sand grains occasionally. There are lots of grains in sand, and eating disconnected individual grains, which are like separated individual animal cells, wouldn't be very painful or harmful to the sand. The sand shifts around, changing its layout of grains and therefore personality anyway.
Part 6.
Hairy Harry's hairy children. The children take after Harry for being hairy. Hairy Harry. Hairy Harry has hair made of the real hair-like mineral halotrichite, which you can see on the right. In real life, some birds might have chicks that are underdeveloped, like being pink and featherless. Other birds might have chicks that are more developed. So precocial roxen birds and altricial roxen birds. So precocial roxen birds, so this includes pebbles. So these precocial roxen birds, they're not pink, well-developed eyes, strong legs, can have hair/feathers, and parent needs to eat more food to produce more developed offspring. So these are more developed, these precocial rocks and birds. So if we move on to altricial rocks and birds, so this includes Hairy Harry's child. So these altricial rocks and birds can be pink, hairless/featherless, blind, more time to develop, and therefore more time to develop brain, and therefore have a bigger brain as an adult. Pebbles is part human, and their rock parent is quite intelligent, so they are actually quite intelligent despite being more precocious. Pebbles is not necessarily Harry's child. The pet rock carried its baby around on its back. So Harry's child develops, so they get hair, well-developed eyes, and strong legs, as you can see. So they've got the arms, the legs, the eyes, and the mouth and stuff. And we've got the hair. So we have real volcanic glass on the left. Here, so real cooled lava known as Pele's hair. That's what this is. And I used a clump of head hair I found, which is meant to represent the rock's hair. So Harry's child's hair is meant to be strands of volcanic glass. Pebbles and Harry's child look similar, suggesting bedrock is a parent of them both, and some of bedrock's material went into making them both. This means the two children are related. and this is bedrock here on the right, so they're apparent. My pet rock, called Hairy Harry, had a baby with one of the pipe cleaner aliens. This is the child. This coral fossil was shaped like an alien head, so I used it. In real life there is a blue hairy mineral called cyanotrichite that contains copper. I therefore used blue hairy pipe cleaners meant to be the mineral for the hybrid's hair. This cardigan has white hairy sleeves, so I used white hairy pipe cleaners for the sleeves. The pipe cleaner aliens came to invade my room, but in the end they invaded Hairy Harry's heart. Hairy Harry's next child has eyes covered by seaweed hair, a typical teenager. The large size of this child of Hairy Harry indicates the pet boulder called Big Lad is also apparent, and material came from Big Lad to form the offspring. Here's Hairy Harry's children. So we've got Hairy Barry, Hairy Larry, and Hairy Mary. Part 7. Humans have recorded history, and this may be a sign of their intelligence. However, ordinary rocks have also recorded history through fossils, indicating ordinary rocks may be intelligent. Here's a real fossil of plant roots at the Great North Museum. This fossil appeared in the original Pet Rocks video as a Pet Rocks pair of trousers. Non-fiction. Humans have nerve impulses called action potentials, and plants can also have action potentials. Human action potentials use sodium ions to depolarize neurons, whereas plants don't use sodium for depolarization in action potentials, and plants use calcium and chloride ions in action potentials. Plants can also react to touch and light, and plants can react to other plants in danger. The mimosa plant can react to touch by rapidly drooping its leaves. In this story, because of these real-life factors, plants have consciousness. When organisms turn into fossils, the organism's ghosts can inhabit the fossil. Because plants can react to touch, the plant fossil's conscious ghost may feel the pet rock wearing them as trousers. The pet rock, however, may not know that their pair of trousers is conscious. We hollowed out the trousers so the pet rock could fit their legs in. The pet rock is part ordinary rock, and so finds it hard to move. The pet rock would therefore find it too much effort to pull their trousers down to defecate. To make it easier, we added a hole to the trousers. The hole may make privacy difficult. We therefore needed to add a flap. A material like cloth would just be blown in the wind and therefore wouldn't protect the pet rock's privacy. Unfastening a flap would just be more effort for a pet rock that finds moving difficult. Therefore, we added a heavy material that gets pushed open like a letterbox every time the rock defecates. The pet rock's waste just drops out. Pet rocks can resemble animals. This pet rock has a shell and resembles a snail, and leaves a trail behind it like a real snail would. In the original Pet Rock episode, there is an octopus or squid-like pet rock. Here you can see their tentacle-like appendages sticking out the bath. During the pet rock uprising, this pet rock kraken pulled me into the bath. Another pet rock then came and saved me. How was the pet rock able to save me? In real life, octopuses sort of have brains at the base of each of their arms. What I used for the pet rock kraken's arms were geodes at the Great North Museum. Because this particular kraken's arms are geodes, the arms are hollow. Because octopuses sort of have brains in their arms, this would be like a human having a hole in their head. The kraken's cavities in its arms means less of each arm can be used as a brain. This kraken's impairment to the brains in each of their arms means my pet rock was able to rescue me. Because my pet rock has a hard time moving, rescuing me led to my pet rock getting post-exertional malaise, which is also a real symptom of chronic fatigue syndrome. Post-exertional malaise is where you overexert yourself and it makes you even more exhausted, and it can last for weeks. It has been a while since the original Pet Rocks episode, and I have now been able to expand on characters not seen since, like Hairy Harry's baby, the fossil trousers, and the Pet Rock Kraken. Thanks.
Part 3.
In humans, there can be two parents and therefore two roles of parental investment. For example, women may produce a baby inside them. In animals, one gender may play a different role in parental care. For example, female orangutans may give more parental care because orangutans are quite solitary, and male seahorses may carry their young before giving birth. These two different levels of parental investment can lead to two genders being common. Why is this rock gender fluid? A grain of sand could break off this sandstone, and eventually the grain of sand could become part of a new rock, a child, if you will. The rock only had to give up one grain of sand, and so this was low parental investment. On the other hand, a big fragment of rock could break off this rock, and the fragment could be the child. In this case, the rock had to invest more of itself in their offspring. They had to lose a larger piece of themselves. Different levels of parental investment can cause different genders. The rock can invest different levels of itself into the offspring, just a grain or a bigger fragment. Therefore, the rock can experience aspects of more than one gender, and that's why the rock is gender fluid.
Part 4.
Animacy means how alive something is. Animacy is a big concept in languages. A human may be at one end of the animacy hierarchy, and a rock that doesn't move may be at the other end of the animacy hierarchy. How animate something is has big effects on the language used, like word order, grammar, and pronouns. If rocks are conscious, rocks may feel like the concept of animacy in language is discriminatory and dehumanizing to rocks. Using inanimate language to describe rocks implies there's nothing going on in the rocks' heads. The pronoun it instead of they is very ignorant to call rocks. In sentences, people come before objects. Usually, for example, you would say a person got hit by a rock, not a rock hit a human. This shows how humans are thought of as more important and come first to rocks. This shows humans' very anthropocentric worldview, where they think they're superior to everything else. This rock thinks rocks may not be able to move or communicate, but would you treat a paralyzed human or a human who can't talk as any less alive or animate? This rock holds very strong views and believes even human language discriminates against them. Like some autistic humans who can't speak, rocks can prefer the term non-speaking to non-verbal
because non-verbal implies there's not as much going on in their head. Further, some languages have different genders. Words for rocks can be masculine in German. Some rocks identify as female or non-binary, and so this is another issue. The argument against changing the language is that traditionalists believe language needs to be conserved. Another argument is that changing and therefore complicating aspects like animacy and gender complicates things and therefore makes languages harder for non-native speakers to learn. If science does begin to back up that rocks are conscious, it'll take a while for culture and cultural norms to catch up with science.
Part 5.
Rocks can't move or communicate, so they're stuck in one place and aren't getting much stimulation. People with ADHD can make the house colourful to stimulate themselves during COVID lockdowns. Autistic people can have sensory issues and can have a sensory room or space. This is so autistic people can regulate their senses with different colours, textures, and smells. While rocks generally may not have ADHD and autism, they can't do much and so can have a lack of stimulation. I therefore made a sensory box to keep some of my rocks in. I added a fluffy hot water bottle case to the bottom of the collection to stimulate the rock's sense of touch. I added different colours to the walls to stimulate the rock's sight. I used pastel colours because they can be calming yet energizing. And I added a little pouch that smells of lavender to stimulate the rock's sense of smell. Hairy Harry is now in the box as well. Rocks in collections may not get touched a lot. In nature, lizards will bask on rocks. You may get starfish or millipedes hiding under rocks. In collections, rocks don't get touched though, and therefore can feel lonely and unloved. They can even get touch starvation. With baby animals, you could give them a toy that looks like a mother animal for them to cuddle. I made a starfish out of a dish sponge for the rock to squish down on. I made a lizard toy to bask on top of rocks. I made millipedes with pipe cleaners. The individual pipe cleaner hairs are like all the individual legs. I added all the toys to the rock's enclosure to simulate touch.
Part 6.
There is a real operation called a hemispherectomy, which can remove half a person's brain. This is to treat seizures and epilepsy. You can see this rock has been split in half. If rocks are conscious, a rock is like a brain. Some rocks getting split in half can therefore be like a rock losing half of their brain. In humans, neuroplasticity is the brain's ability to rewire and take over functions from losing half the brain. Rocks may also have neuroplasticity following losing half of themselves. Rocks may not have some of the side effects of losing half their brain, like blood loss or fluid buildup, and rocks can't really move so wouldn't have weakness down one side. The rock, now being half the size, may have a larger surface area to volume ratio, and therefore could lose water quicker, a bit like blood loss. Some organisms like lichen can dry out and be fine, and this is known as poikilohydry. Rocks can also dry out and be fine, and so rocks are poikilohydric, and fluid loss shouldn't be an issue. In humans, lots of parts of the brain are involved in memory, so memory is spread out across the brain. In rocks, cognitive functions can also be spread out across the rock. This means when a rock is broken in half, both sides will still be able to carry out cognitive functions. In humans, certain brain regions can also be on both sides of the brain. Humans' brains can still be a bit asymmetrical though, and this can be the case with rocks split in half, where the two fragments' cognitive functions aren't entirely the same. In some cases, the rock is the same rock, just with half its brain missing. In other cases, the whole rock was the parent, and the two halves are two offspring. It just depends how the rock reproduces.
Part 7.
The rock is training to reach spiritual enlightenment and has their chakras. They have their legs crossed as well for meditation, and their chakras are... The chakras can be represented in different colours. So we'll have the red sandstone chakra, the orangey rock salt chakra, the yellowy amber chakra, the greenish, possibly copper containing chakra, the fake opalized shell blue chakra, and I'll have the sort of dark bluish chakra, and we have the purplish chakra, and that greyish one is the coral fossil. I'm not sure what the purple is. So that is all the rock chakras to help it reach spiritual enlightenment.
Part 8.
So here we have a brain, and we can see it has folds in it. So this is like around the cerebellum area, and the folds are called gyri and sulci, like the peaks and troughs of the folds. But then we also have folds in this part of the brain in orange, and these are called folia. And so they both increase the surface area of the brain areas to allow you to, they can make you more intelligent and stuff like that, because they can pack more into a smaller surface area. And basically, if we look at rocks, if we look at the top picture, we can see folds in rocks. So this is a bit like in the brain. So rocks could be conscious. They could have these folds in them that are real. It could be like the folds of the brain. They could make them more intelligent, could increase the surface area and stuff like that. So these folds at the top are a bit like the gyri and sulci, like the folds of the blue area, the cerebrum. So this is the blue area, cerebrum, orange area, cerebellum. I hope I said the right names before. So but then if we move on to the bottom picture, these are ripples in rocks as well, and then the ripples are a bit more like the folia, the folds in the cerebellum, because basically if you compare the folds in the blue area, the cerebrum, to the folds in the orange area in the cerebellum, you'll find that the folia are much smaller. The folds in the cerebellum are much smaller and tightly packed, and run more parallel to each other. So then if we look at the folds in the bottom picture, they're not the folds in the same sense pulls, and we're seeing that they're much smaller compared to the folds in the top picture, and they run more parallel to each other. So the bottom picture, that's more like the folds in the cerebellum, which are called folia, and the top picture is more like the folds in the cerebrum, which are called gyri and sulci, because the bottom picture, the ripples are much smaller and tightly packed and run more parallel to each other, just like the folds in the cerebellum.
Part 9.
So today we're going to talk about theory of mind. So that's just basically understanding other people's perspectives. And we're going to test if rocks have theory of mind. So I've got a cookie box. And so I say to the rock, what do you think's in the cookie box? And they'll think cookies because it's a cookie box. But actually, it's a banana. So now that the rock knows that there's a banana in there, someone else comes along, we'll just say little Teddy comes along and sees what's in the box, and they don't know what's in the box. So we ask the rock, what does the Teddy think's in the box? And if the rock says, so the Teddy would think there was a cookie in the box because they've not seen it before and it's a cookie box. But actually there's a banana in there. But the Teddy doesn't know there's a banana in there. But the rock might have trouble understanding other people's perspectives and might assume the Teddy thinks there's a banana in there because the rock knows there's a banana in there. So we're going to test that. So we've got so what we're going to do with the rocks, we've got a sheet of paper and it says, so we've got cookies there and banana there, and we're going to get the rock to point to what they think's in the box. So we'll just do that now. The rock's going to point to what they think the Teddy thinks is in the box. So the rock is pointing to the banana. So are you sure about that, rock? Oh no, they think cookies. So then they knew that the Teddy wouldn't know about the banana, so they have theory of mind. So rocks have theory of mind. Part 10. Can rocks be creative, produce art and abstract impressions? The rock is painting a picture. You can really feel the raw emotions in this piece. That's it, rock. Let it out. Let it all out. I say rocks are conscious and intelligent, but people say, show me the empirical evidence. Well, here is irrefutable proof rocks are conscious. Rock, point to yes if you're being truly creative, or point to no if you're just doing this for a reward. Looks like they're pointing to yes. So rocks can be truly creative and produce art. The painting is called Flickering Embers Amidst the Void of Nothingness. The lines look like smoke rising. I interpret the red marks as the fire burning within the rock. The rock wants to do something and has a drive to do it. Ultimately, the red marks are surrounded by nothingness, which shows despite the rock's efforts, they still lack any purpose or meaning in life. A fire can't spread or materialize if there's nothing around it to emblazon. The rock would go on to finally reconnect with other rocks in their family. They would look after children. They would finally find purpose and meaning in life. Part 11.
Conscious organisms can self-regulate and oppose changes to their environment. If rocks are conscious, they would do the same. If a river weathers a rock, the rock will self-regulate by becoming more spherical. Spheres have the lowest surface area to volume ratio, which means the rock will have less surface area to be weathered and the rock will be weathered less, therefore opposing the change of a weathering environment like a river. The rock therefore self-regulates and reduces weathering.
So just like rocks are round, sea glass is also round, and sea glass is what's called amorphous. so it doesn't have a crystalline structure or grains. And that's interesting because it's round means sea glass is also self-regulating. So that basically means anything can be conscious, not just rocks, and even something like glass can be.
Part 12.
The weapon was unlike any the world had seen, a device capable of dissolving the carbon-nitrogen bonds that held life together. Every biological organism would perish, leaving only the rocks untouched and triumphant. The hateful halide held this power in his crystalline grasp, ready to obliterate humanity. "It's not murder," the halide hissed, its voice sharp as fractured glass. "If someone charges at you with a knife, it's called self-defense to strike them down. Humans have been killing us for eons, grinding us, melting us, mining us like we're nothing. They're the ones wielding the knife. Our survival demands their extinction." The human, pale but unwavering, shot back. "And what of the creatures that die when you're thrown onto the icy roads? Salt kills too, like the worms that writhe and perish on the pavement." The halide's glimmer darkened. "Who put us there? Humans did. You forced us into that role. And worms, they grind minerals into dust to digest their food. They harm us as much as we harm them. But we do not need to kill. We are passive. It's life, biological life that devours to survive." The human's eyes narrowed. What about the volcanoes that unleash rivers of molten rock, or the earthquakes that tear the world apart, killing everything in their path? Rocks have spilled blood long before we ever did. Tsunamis, landslides, they've taken countless lives. And salt, like you, poisons water, making it deadly for those who drink it. The halide faltered. "It's not our doing," it murmured. "Water dissolves us, not the other way round. Water is the villain in this tale, not salt. Biological creatures have hurt us since the dawn of time, long before your kind could ever feel pain. We have always acted in defense." The human's voice softened, cutting deeper than before. "You may despise us for our cruelty, but aren't rocks just as guilty? Aren't we all both the victim and the villain, both innocent and guilty? You hate us because we harm you, but have you ever considered that what you hate in us is merely a reflection of what you hate in yourself?" The halide recoiled, trembling at the words. It stormed away, pacing back and forth, the weight of its own argument crashing down upon it. Should it set off the weapon? Should it destroy the humans that had tormented it? Or was it wrong? Confusion twisted its crystalline mind. It had built its entire existence on this single purpose, to kill. But now doubt gnawed at it, unraveling its certainty. If it didn't kill the humans, if it didn't fulfill its mission, then what was it? What was left? The halide hesitated, its resolve crumbling like the salt it was made of. For the first time, it postponed the attack. It needed time to think, time to decide whether vengeance was worth losing its soul.